Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit more GCSE exam practice with Bathilda, the Batty cat. This is GCSE Maths higher level. Now what we've got here is Bathilda's wanting to know how much she weighs. So there she is, sat on a handy force meter that she's got. Now when she sits on there, it reads a value of 230 kilogram meters per second squared, commonly known as newtons. So that's the force she is exerting. That's correct to two significant figures. In order to calculate her mass, she's going to use F equals ma, a very famous equation, force equals mass times acceleration. And she knows that in this case, the acceleration she needs to use is acceleration due to gravity, which has a value of 9.81 meters per second squared. That's correct to three significant figures. So the first thing you need to do for part A is calculate, please, the upper and lower bounds of F and A given the number of significant figures they have. Right, you do that bit now. Okay, this is pretty easy. Correct to three significant figures, it means that last one has been rounded. So it could be half a unit higher or half a unit lower. So A could be anywhere from 9.815 at its maximum to 9.805 at its minimum. Okay? Same with the force. It's correct to two significant figures, which means that that is the one that's been rounded. So we need to go half one of those units up or down. Please note, it's not half a kilogram meters per second. It's not half one of those, it's half one of those. So the maximum that could be would be 235, and the lowest it could be would be 225. Okay, pretty easy on those, hope you got them. Right, the next thing we need to do is to calculate, please, the maximum and minimum values of m. Using our formula there, the maximum and minimum values, correct please to 5 decimal places in these. Okay, off you go. Right, now this one, I hope you didn't get fooled by using just the top values and the bottom values together. M is equal to force divided by acceleration, which means to get the maximum value of m, we need the upper bound of F and the lower bound of A. So, to calculate the upper bound, here's how you do it. Okay, those are all the digits on my calculator. Rounding to 1, 2, 3, 4, 5 dp, we don't actually have to do anything on that. And here it is for the lower bound. Now when we round that to 5 decimal places, 1, 2, 3, 4, 5, we need to do some rounding. So the answer there would be 22.92410. And you must put the 0 in. If it says 5 dp, it means 5 dp. You wouldn't get the mark if you didn't put the 0 there. Okay, hopefully you got those. And the final part of this question is, please give a value of m to a suitable degree of accuracy. Do that now, please. Now on here, although we're using 3 sig fig and 2 sig fig for the values we've got, the value we have to quote for m can only be 20 to one significant figure. The reason for that is that when you look at here, we've got a value of 22 point something and a value of 23 point something. The only figure we're sure about is that 2 at the beginning. We can't quote it as 22 point something because that one says 23. So we have to only quote the 2. One significant figure is all we can get out of this. So 20 to one significant figure. Okay, hope you had fun with that. That's enough for this question. I'll see you in another video. Bye for now, Batty fans.
Mwahaha! Mwahaha! Mwahaha!